Hello everyone, we are going to look into how do we use statistics tests in Python. We're going to see the implementation of various statistics tests in Python. So here we are going to demonstrate z-test, t-test, how do we make use of proportion test, two sample set test where there are independent samples, paired t-test, and also we are going to look into chi-square test, one-way ANOVA. So these are the various tests that we are going to look into. So first of all, let us begin with the most common test that we all know, which is the z-test. So here whenever we make use of these statistics tests in Python, we do not make use of the tables. Rather, using the p-value, it gets compared with the level of significance, that is the alpha value, and on that basis we decide if we should reject the null hypothesis or we fail to reject the null hypothesis. So here we use the p-value method, and so the test will give us the p-value, we compare it to the alpha. If the p-value is less than alpha, we reject the null hypothesis. So z-test is we are going to use here. So here we are going to use the z-test to test the claim if the mean of sample is 156. So here we are going to use z-test to check if the mean of the sample is 156. Import, these are the import statements that we make use of, and then there is using random.randint. Here we generate 30 numbers randomly in the range from 120 to 180, and these are the various numbers that get generated. Let me just randomly generate it again, and here these are the random numbers that are there. I want to check if the null hypothesis states that mean is equal to 156, and so the alternate hypothesis will be mean is not equal to 156. So I call the z-test method, passing sample1 to it, and the value that I want to check is 156, and it is a two-sided test. So here we are using equal to and not equal to, and so it is a two-sided test that we have. Now here when we run the test, it is going to return me the z statistic and the p-value that is there. So usually we using this z statistics, we refer it with the tables to get the corresponding value. So here to get the corresponding critical value. So now here we only make use of the p-value. Here the p-value is 0.0022, which is less than 0.05. Here level of significance has been maintained as, I can even put it generally, let alpha be equal to 0.05, and here I check it against the alpha value, and here p-value, that is with this particular random sample, I got p-value as 0.4576, and so it shows fail to reject the null hypothesis. Every time it generates different samples. So fail to reject the null hypothesis, and so that means mean is equal to 156. Let me also display the sample mean so that we understand if it is so here we reject the null hypothesis. Let me generate some other random sample. It is 153. So it is failing to reject the null hypothesis. Just to get some approximate idea around the mean and why is it taking that decision. So here we see that it is 153. It is kind of similar to 156, and so it is accepting it. Let me show you with 151 also it accepts, and let me put the numbers here itself as 180 to 200. It rejects null hypothesis. P-value C, it is 0.000, considering that the numbers that are there are just not matching with the values that we want to check, because I have I'm asking for the mean to be 156, and the numbers that I've provided here are totally different. P-value is 0.00, that is, it's those are way different from what we want to do. So here, let me give the numbers that we had earlier. Yeah. Okay. Now let us consider one sample t-test. One sample t-test gets used whenever we know the population standard deviation, and also if the standard, if the and only if the number of samples is lesser. So here we have some sample here, and I want to check if the mean of the sample is 30 or not. So again, this is an so here these are the t statistic and the p-value which are getting generated. T statistic is 1.8 and the tested, and the p-value is 0.08, which is more than 0.05, and so it fails to reject the null hypothesis. So I can provide a sample like this, I can generate random numbers like this, so any way it is possible. So here the function that we use is t-test1samp. Now t-test1samp helps me to get this. Okay, let us now consider one sample proportion test. So here we are going to consider one sample proportion test. So here sample size is 100, out of which 25 are found to be defective, and so we want to check, test the claim if the proportion of defectives is 0.2. So here we make use of that is, out of 100 we have actually got 25, and we want to check if the proportion of defective samples is 0.2. So here we call for proportion set test. This is the function or the method that we are going to use. Count is equal to defective, so here it is 25, number of samples is 100, the value that we are checking for is 0.2, and the proportion variance is specified to be 0.2 again. So when we run this, here it is 0.2113, and so we fail to reject the null hypothesis. We fail to reject the null hypothesis here, so it is 0.2113. 0.2113 less than 0.05, which is false, and so it shows fail to reject the null hypothesis, indicating that the proportion is at a 0.2 level of that is, the proportion of defective samples is 0.2. Let me put some other value here. So here if it is 200, then it shows the p-value to be really less, and so it rejects null hypothesis that it is 0.2, rather it is, so here in this case it would be a 0.1 or so it rejects. If I give, let's say 2 with 10, so here again it failed to reject the null hypothesis. That means it accepts the null hypothesis that it is 0.2, which is very true in our case. If you see, it is 2 and 10, so it is 0.2 in any ways. Now let us consider two sample Z test. So these are all one sample test. Let me also demonstrate. So here let me also demonstrate how do I modify it to be a one-sided test, which can be smaller or larger. So here I say smaller. So smaller means I'm checking for the mean to be less than 156. Here the mean is 156, and I can also specify it to be larger. So here I am checking if the mean is larger. So if I do not specify, so here I can have smaller is the other alternate value, or I can also have two-sided. So like this I can check for the one-sided test using smaller or the larger parameter. Similarly here also for the t-test also. So here we have count equal to defective, number of observation is the sample size, and we have value is the value specified as 0.2 and the proportional variance as specified as 0.2. So here value indicates what is the hypothesized population proportion, and proportion variance is the assumed population proportion for variance calculation. So using this we check for the value. So here consider to explain more on this value and the proportion, hypothesized population proportion, and also proportion variance is nothing but the assumed population proportion for variance calculation. So now here if I set prop var the parameter as none, the function will use the observed proportion from the data to compute variance. So here I am telling that consider the assumed, use 0.2 as the assumed true proportion when calculating the standard error. So now here another, that is if I specify none, then in this case the value will be taken as such. So this 0.2 refers to the hypothesis. And this can be specified as none also, and then it will, if I specify it as none, that means the function will use the proposed observation from the data to compute variance. So this is the details with the one sample test. So we saw one sample Z test, one sample T test, and one sample proportion test. In the next video, we will look into the two sample Z test, two sample T test, paired T test, and then chi-square will be covered in another video.